Hi, today we're going to be representing algebraic relationships. So our objective is to use a word problem to make an equation, a table, and a graph. And this is page 54. All right, so I look at this word problem, or really just piece of a word problem, and it says Maria is 4 years younger than her sister Edith. So the first thing I want to do is figure out, okay, well, what are my two variables? What's my independent variable and what's my dependent variable? And typically on a table, you're going to see the x written here and the y written here, or the independent and then the dependent. So if I have, what are the two things? Well, Maria's age and Edith's age. So which one's my independent? Well, when we're talking about ages, I go with whoever's older would have to be first, so that's going to be our independent variable. So let's see, which one's older? Well, that means Edith would have to be older because Maria is younger. So we're going to say right here, this is Edith's age. And this one is Maria's age. Now, we aren't already given any values, but we can just pick some numbers, plug it in, because if we can just pick some ages, we can find Maria's age or vice versa, and then we'll be able to make an equation and graph and really see what the relationship is. So let's see, we need to pick an age for Edith. Now, I know Maria's 4 years younger, so I wouldn't want to pick anything lower than 4 here. So let's just start with 5. When Edith is 5, if Maria is 4 years younger, how old would Maria be? Well, she'd be 1. All right, what about when Edith is 6? If Edith is 6, again, Maria's 4 years younger, so she'd be 2. When she's 7, she'd be 3, and 8, and so forth. Okay, so now we can kind of see a relationship here. And so we'll put that there. Now, I'm going to put a little x here, meaning no matter what am I doing? No matter what number I put in for Edith's age, what am I doing to find Maria's? Well, if I look from here to here, it's going smaller, so I'm either subtracting or dividing. And in this case, since she's 4 years younger, I'm subtracting 4 each time. So this would just mean x minus 4, whatever Edith's age is, and then take away 4 would give me Maria's. So already, I can already tell that my equation will then be y equals x minus 4. Okay, well, I've already got some points here. This is like my ordered pair, 5, 1, 6, 2. So that means I can graph it. And now I notice these are all positive, so I really only need quadrant 1. So this is 0. Now, if I count by ones, 1, 2, 3, 4, 5, 6, I wouldn't get all the way to 8. So I want to make sure I'm going to pick a scale that's going to encompass all of the numbers that I'm using in my table. So if I count by 2s, that should be okay. So let's make this 2, 4, 6, 8, 10, 12. Remember, this is your x-axis. This is your y-axis. Okay, so I also need to put my labels here. So which label should I put here? Well, x is Edith's age. Remember, your independent variable is always x, okay? So we'll put Edith's age. And I'm going to put a y because this is in years. And then we have Maria's age. It's also in years. Okay, now I can graph this right here because I look at all Maria's ages. Now these are small. I don't have to count by 2s here. I could just count by 1s. So I'm going to do that. So this would be 1, 2, 3, 4, 5, etc. Okay, so let's graph this. When Edith is 5, so 5 would be right in between 4 and 6. Maria is 1, so it'd be right there. Okay, and when she's 6, Maria is 2. And when she's 7, Maria is 3. And when she's 8, Maria is 4. And I could continue, like when Edith is 4, Maria would be 0 or just being born. And I could continue on the trend here. She's always going to be 2 years older. Okay, and I'm going to put an arrow there. I'm not going to put an arrow going the other way because Maria's not going to be a negative age. The smallest she can be is 0. Okay, so So now I look at everything and that looks great. I've got my table, I've got my equation, I've got my graph, all of these representing the relationship between Maria and Edith's age. So let's look at another example. Austin can walk 5 kilometers every 2 hours. All right, well, what are my two variables here? What are the two things I'm talking about? Well, I'm talking about kilometers and hours, which means distance and time. So which one would be my x and which one would be my y? Remember, x is always independent. So would I know how far they have gone, or would I know the time first? Which one would come first? Well, I would need to know the time first, and then I could calculate how far that they have traveled, okay? Assuming they're going at constant speed. All right, so that means that my time is independent, and I'm gonna put HR for hour. And then distance would be dependent, and I'm gonna put km for kilometer. Okay. So it already told us this right here, 2 hours is 5 kilometers. 2 hours, 5 kilometers. Now, because I don't know how much 1 is yet, I'm not gonna put 3. I wanna make sure I keep it in increments of 2 so that I'm actually staying true to this. 2 hours would be 5 kilometers. So then 4 hours would be 10 kilometers, and 6 would be 15, and 8 would be 20. All right, so now I need to figure out, well, what exactly is going on here? I know it's increasing, so that means additive or multiplicative. This would be plus 3, but 4 plus 3 is not 10, so it doesn't look like additive. So multiplicative, 2 times what would be 5? Well, I can't think of any whole number, which means we must be using a decimal. So 4 times something, 10, yeah. So what I could do, if I don't know what I'm multiplying by to get 5, you can divide these and figure it out. So let's see. 5 divided by 2. Well, that goes in twice, which is 4. I get 1 left over. Add a decimal and a 0, bring it down. 2 goes into 10 5 times, which is 10. All right, so 2.5. So I'm multiplying by 2.5. Let's see, 4 times 2.5. Yep, that would work. Okay. So now, no matter what, whatever my value is for x, what am I doing to it? Multiplying by 2.5. So how would I write that in algebraic form? I'm not going to put x times 2.5, okay? I'm going to write 2.5x. All right, so then my equation would be y equals 2.5x. Okay, so now when I graph it, let's look at the values on my graph. I noticed that on the x values, I have to go all the way up to 8. So maybe like this, counting by 2s would be okay. And on the y values, I need to get all the way up to 20. So can't even count by 2s. 3s, no. Let's see. 4, 8, 12, 16, 20. So I could count by 4s, okay? I could also count by 5s if I want to make my life easier, since I already noticed this is going by 5s. All right, so let's put our labels on. This is x. This is y, and we know that the x, or the independent variable, is time in hours, and the dependent is distance, which is in kilometers. Okay, and so again, I'm going to count by 2s here. 2, 4, 6, 8, 10, and I'm going to choose to count by 5s. 5, 10, 15, 20, 25. All right, so here are my ordered pairs, 2, 5. So 2, 5, 4, 10, 6, 15, 8, 20, and so forth. And again, I can go part of an hour, so I could go part of the miles. So I would connect these. And I'm not going to go backwards because, again, you're not going to have negative time and gone a negative distance. Okay? So we have our table, our equation, and our graph that all go with this situation. So now that kind of wraps up independent, dependent variable, graphing coordinates, tables, equations, graphs. So keep practicing, and thanks for watching.